Hi there, this is gonna be another video about the false position method because as I always say, the more the better. So let's start with the function f of x, which this time is gonna be different from the other that I used in a former example, and it's gonna be x to the third minus 9x plus 1 equal to 0. As our starting point, we're going to have to choose two starting points. One of them has to give us, once we plug it into the function, a positive value, and the other one, x of 2, once we plug in into the function, has to give us a negative value. So let's see. As x1, I can choose 2.9, and as x2, I can choose 3. So if I plug into my function x of 1, so f of 2.9, I'm gonna get 2.9 cubed minus 9 times 2.9 plus 1, which is actually gonna give me 24 0.39 minus 26.1, which is actually going to give me negative 1.71. So we got a negative value, which is fine. Now we expect x2 to give us a positive value. So f of 3, if you plug 3 into our function, we get 3 cubed minus 9.3 plus 1, which gives us 27 minus 27 plus 1, so 1. Those two cancel out, so we get 1. So we're good because we basically got a negative value and a positive value. So if we try to draw our graph, sketch it here, we got x and y, which is a 0. So our two starting points are going to be let's see. So this one is going to be 2.9 and this one is going to be 3. It's terribly out of scale, but it doesn't matter. Just an example anyway. So 2.9 is actually going to give us a negative 1.71. So something like negative 1.71 here. And 3 is actually going to give us 1. So like here, 1. So we actually expect that if a function is continuous, that the function is gonna there must be a value which is gonna be 0. So there must be a value which is gonna intersect the axis. So let's see. Well, I'm gonna write the formula once again because it helps you memorize it. So the more you write it, I actually suggest you to write it every single time in your exercises because if you have a copybook and you keep everything clean and ordered, and you go over it like I don't know, few months apart for whatever reason, everything feels like ordered and perfectly fine, and you gotta know what you were doing back then. But if you don't write the formula, perhaps you forgot, perhaps you don't remember it anymore, and so on. So certainly suggest you to write it, always write it. So for the false position method, we have xr equal to x2 times f of x1 minus x1 times of f of x2, everything over f of x1 minus f of x2. There we go. So once again, what the formula says is that I'm gonna get an x of r1, which is gonna be given by x2, so 3, times f of x1 so negative 1.71 minus x1, so 2.9 times f of x2, so 1, everything over f of x1, so negative 1.71 minus f of x2, so 1. So if we compute this, we got negative 5.13 minus 2.9 over negative 2.71, which is going to give us negative 0.03 over negative 2.71, which is the same as saying 8.03 over 2.71, which is going to give us 2.96. There we go. So basically we're gonna get like 2.96, which is here. So now we're gonna plug 2.96 back into our function and see whether we get positive 2.96, a positive or a negative value. So 2.1, if we plug it back into our function, we get 2.96 cube minus 9.2.96 plus 1. So we got 26.01 minus 26.64 plus 1, so 0.37. So look at that, we got a positive value. So like here, like 0.37, so it's a positive value. Therefore we're gonna go on, but we're not gonna use 2.90. We don't expect the function to cross the axis between 2.96 and 3 like it happened in other examples, but this time we expect it to cross the axis between 2.9 and 2.96. So we're gonna look for a value in this interval. So this means that if we go on with XR2, 2.9 is going to be our x1, and 2.96 is going to be our x2. So 2.9, if we look at the formula, we get x2, so 2.96, times f of x1, so f of 2.9, so negative 1.71, minus x1, so 2.9, times f of x2, so 0.37. Everything over f of x1 minus f of x2. So f of x1, negative 1.71, minus f of x2, so 0.37. So if we compute this, we get negative 5.06 minus 1.07, everything over negative 2.08, equal to negative 6.13 over negative 2.08, which is like saying 6.13 over 2.08, which gives us 2.94. There we go. So we got 2.94, which is gonna be our new value, so something like here, 2.94. And now we're gonna plug 2.94 back into our function. So f of 2.94, if we plug it into our function, we're gonna get 2.94 cube minus 9 times 2.94 plus 1, which is going to give us 25.41 minus 26.46 plus 1, which is going to give us negative 0.05. So again, we get a negative value. So, but it's really then close to 0. So we get negative 0.05, like negative 0.05. So like here. So we can expect our function to be like this and curve this way. So this is our best guess for this function. So if we go on, we will get a closer, again, a closer to 0 value here. So, you know, once we computed it, we had 2.94. We actually found out that it's negative. So then XR3, I'm not going to do XR3, but it will be between 2.94 and 2.96. So something in between, something like 2.95, something like that. And then we will compute it at that very point and find something really, really damn close to 0, because negative 0.05 is already really close to 0. So this is about it. I'm gonna do one more example in the next video. So stay tuned.